Okay, warm up 5.5. First question says, which two angles are definitely congruent in this diagram? Just based on this given info. So forget the info from problem number 2. Let's say we just had this diagram. Well, it looks like, these angles might be congruent, but we don't have a way to say that. But what we can do is use the parallel lines, okay? So I've got that the top and bottom here are parallel, so we can use those. I call them tracks. If you extend those, then we've got two sets of parallel lines here. And if I have, there's three different transversals that run through those two green lines. So I've got, this, and this are all transversals. So transversal is just a line that intersects two different lines. Okay, so I've got three of them to choose from, but if I use this one, then I can't create two different angles that are in those two triangles. Okay, so I would need another line to create an angle that's in both triangles. I could create that angle at the top, but there's no other angle that's in the triangles. So the transversal that I want to use is this one. Because when I use this one as my transversal, then I can say, okay, I've got this angle that's created by those three lines that I just highlighted, and this one as well. Okay, I don't need those other two lines. I could wiggle those other two lines around, and it wouldn't change the fact that these two angles are going to be congruent. They're going to be congruent because they're alternate interior angles, and alternate interiors are always congruent when the tracks are parallel. So it's these two is my answer. So I'm going to call that angle BAC. I don't want to just call that angle A because there's a bunch of different angles A's in this diagram, but there's only one angle BAC. So BAC, that's that one at the top, and I'll call this one DCA. Okay? All right. So now this says use the diagram above to complete the proof. So we've got some given info here, right? That's my given info, so my reason for that is going to be given. Okay? And then I want to say something is congruent by the alternate interior angles theorem. Well, that's what we did in part 1, right? We showed that these two angles were congruent by the alternate interior angles theorem. So I'm just going to copy what I have here there. Angle BAC is congruent to angle DCA. Okay. Next up, I have something is congruent to itself. So AC is this line segment going down the middle here. So I'm going to say, okay, this is congruent to itself. I like to mark it like that. Anything is congruent to itself by the reflexive property of congruence. Okay, and I'll just do that just to indicate property of congruence. All right. And then I want to show that the triangles are congruent. And just looking at this, right now I've only got one set of angles and one pair of sides. It's not enough, but I actually forgot that in the given info they gave us another piece, right? Usually I like to put the given info into the picture right at the beginning, and the parallel lines were already in there, but this wasn't, and I forgot to put it in, but that's okay, we can put it in now. So AB is congruent to DC. Well, that's the top is congruent to the bottom, and now we do have enough for congruent triangles. We've got two sides in each triangle that are congruent and a pair of angles, and this angle is the included side in each triangle, meaning it's the angle between those two marked sides, so it's created by those two the two highlighted sides there. So this is going to be the SAS triangle congruency theorem. Okay, the A goes between the two S's to indicate it's an included angle. Okay. All right, that's it for the warm-up. See you next time.